We're going to test your knowledge about different kernels used in Gaussian process regression, a powerful machine learning method for regression tasks. Think of kernels as the building blocks of your GPR model. They determine how data points influence each other in the model. Get ready to dive into the specifics of RBF, mattern, and dot product kernels and how we combine them. It's gonna be fun. This is a multiple choice quiz. I will present you with statements about GPR kernels. You select all correct statements. Pay close attention to details. Some statements might be subtly incorrect. Let's see how well you know your kernels. This question focuses on the properties of the radial basis function, RBF, mattern, and dot product kernels, as implemented in the popular Python library, Sklearn. I will guide you through evaluating each statement. The radial basis function, RBF, kernel is indeed a stationary kernel. This means, RBF's output solely depends on the distance between two data points. If you move the points and their relative distance remains constant, so will the kernel's value. This makes it suitable for smooth, globally similar datasets, such as data with continuous behavior. Let's move to the next one. The mattern kernel is actually stationary asterisk, not non-stationary. The statement is incorrect. The flexibility that mattern kernel offers comes from the new parameter in the equation. It doesn't alter its stationary nature. The dot product kernel calculates the dot product of input feature vectors. The dot product is essentially a measure of linear similarity, making this kernel highly suitable for datasets where the relationship between inputs is linear. In scikit-learn, the backquote plus backquote operator adds kernels, meaning their outputs are summed. The backquote asterisk backquote operator multiplies them, meaning their outputs are multiplied. Think of it like adding or multiplying functions. The result is a new kernel. This simply indicates the available options to choose from for the quiz. I'm talking about the different types of kernels used in Gaussian process regression, GPR, a powerful machine learning technique for modeling relationships between data points. Think of a kernel as a function that measures the similarity between two data points. Scikit-learn, a popular Python library, provides several commonly used kernels. This question tests your understanding of some of the most common kernels used within the scikit-learn library. You'll need to know their properties to pick out the correct answers. In scikit-learn, when you combine kernels, plus means you add the outputs of the individual kernels. Asterisk means you multiply the outputs. It's like having building blocks to create more complex models. For example, if kernel A produces a value of 2 and kernel B produces a value of 3, then A plus B will produce 5, and A asterisk B will produce 6. I'll clarify the mattern kernel here. The mattern kernel is actually stationary, not non-stationary. The statement is incorrect. Its smoothness is controlled by a parameter, nu, but this doesn't change the fundamental fact that it's stationary. It only depends on the distance between points. The dot product kernel excels at modeling data where the relationship between input values is primarily linear. It computes the dot product of the input features. It's a good choice when you expect a straight line type of relationship between inputs and outputs. The radial basis function, RBF, kernel is a stationary kernel. Stationary means that its output depends only on the distance between your data points. It doesn't care about the actual location of the points, only how far apart they are. This makes it a good option for modeling smooth and consistent data. This question focuses on understanding different kernels used in Gaussian process regression, GPR, a machine learning technique for regression tasks. We'll explore the properties of a few popular kernels. Think of kernels as ways to define relationships between data points. The choice of kernel significantly influences the model's performance. I can combine kernels using addition, plus, and multiplication, asterisk. If I add kernels, the new kernel's output is the sum of each individual kernel's outputs. If I multiply them, the output is the product. This lets me create more complex kernels that better fit various datasets. The dot product kernel is ideal for data showing a linear relationship. It calculates the dot product of input features, which means it's most effective when the relationship between your input features and the output is best described by a straight line. Think of it like finding the correlation between your inputs and outputs. It's really useful when there's a clear linear trend. The radial basis function, RBF, kernel is stationary. This means its output solely depends on the distance between data points. If points are close together, they'll have similar outputs regardless of location in the input space. This is suited to datasets showing smoothness and consistent relationships across all points. The statement is incorrect. The Mattern kernel is actually stationary, unlike what this option states. While it does offer flexibility via a smoothness parameter, nu, it remains stationary. Don't get fooled, its adaptability doesn't mean it's non-stationary. I'm selecting kernels for Gaussian process regression, a machine learning method that predicts continuous values. I'm using scikit-learn, a popular Python library. I'm answering a multiple-choice question about Gaussian process kernels. The radial basis function, RBF, kernel is a popular choice because its prediction for a new point only depends on how far that point is from existing data points. Think of it like this: the closer a new point is to existing points, the more its prediction relies on those neighbors. This is called stationarity. The dot product kernel excels at capturing linear relationships in the data. It computes the dot product of the input vectors, which is the core of linear algebra's description of lines. So, if I suspect a linear trend in my data, this is a great kernel to use. Scikit-learn lets me combine kernels. The += operator adds the outputs of two kernels together. The *** operator multiplies them. This gives me flexibility to model complex relationships by building up from simpler kernel components. These are three specific kernel functions I'm considering. Each has its own strengths and weaknesses, making them suitable for different data types. This is a multiple-choice question, testing your understanding of Gaussian process regression kernels in scikit-learn. Let's see how well you know your kernels. This question asks you to identify true statements about several kernels used in Gaussian process regression with the scikit-learn library. I'll help you understand each kernel and their properties. This refers to Gaussian process regression, GPR, within the scikit-learn machine learning library. Scikit-learn provides a convenient implementation of GPR. This is the overall topic. We'll focus on several specific kernels used within Gaussian process regression. You'll learn about the RBF, Mattern, and dot product kernels, which are common choices. The dot product kernel works best when the relationship between your input data points is roughly linear. Think of it like this: it's good at finding relationships that can be represented by a straight line or a plane. In scikit-learn, combining kernels is easy. The += adds the results of the individual kernels, while *** multiplies them. It's like adding or multiplying regular functions. This statement is incorrect. I want you to note that the Mattern kernel is stationary, not non-stationary. It offers flexibility through its parameter but remains stationary. This means that it doesn't change its properties based on the location of the inputs. The RBF kernel is stationary, which means it depends only on the distance between data points. Think of a circle. The further you get from the center, the smaller the value. This sets the stage for our problem. I will be testing your knowledge of GPR kernels. This question focuses on understanding different kernels used in scikit-learn's Gaussian process regression, GPR, a powerful machine learning technique for regression tasks. We'll explore the properties of several common kernels, like RBF, Mattern, and dot product, and how you can combine them. Get ready to boost your understanding of GPR. This is a multiple-choice question testing your knowledge of Gaussian process kernels within the scikit-learn library. You'll need to identify which statements accurately describe the behavior and properties of these kernels. Let's see how well you know these kernels. The radial basis function, RBF, kernel is a popular choice because its output depends solely on the distance between data points. This stationary property means it's ideal for modeling data where relationships are consistent regardless of location in the input space. Think of it as measuring similarity based only on how far apart points are. I'm going to correct a misconception here. The Mattern kernel is actually stationary, not non-stationary. While it offers a parameter, nu, to control smoothness, allowing it to handle sharper changes than RBF, its core function still relies on the distance between points. It's just more adaptable than the RBF. The dot product kernel is specifically designed for linear relationships. It uses the dot product of input features, which directly reflects the linear correlation between them. So, if you suspect a primarily linear relationship, this is your kernel. Combining kernels is a fantastic tool for creating more complex models. The plus operator adds the outputs of individual kernels, while the asterisk operator multiplies them. This allows you to build hybrid kernels that capture various aspects of the data. This entire exercise is a multiple-choice question designed to assess your understanding of Gaussian process regression and its kernel functions in Sklearn. I'm using Gaussian process regression, a powerful machine learning method, and exploring different kernels to find the best fit for my data. Kernels are functions that define how similar data points are. They're crucial. Let's test your knowledge of these kernels with a multiple-choice question. Get ready. We're discussing different types of kernels in Sklearn's Gaussian process regression. These kernels are mathematical functions that define the relationship between data points. Think of them as lenses that let us see patterns in data. The radial basis function, RBF, kernel is a popular choice. It measures similarity based on the distance between data points. It's like saying, the closer, the more similar. The Mattern kernel is another important one, offering a parameter to adjust its smoothness. This flexibility makes it useful for a wider range of data patterns than the RBF kernel. The dot product kernel is specifically designed for data where the relationship between points is primarily linear. It's perfect when you have a straight line kind of relationship. It can even combine kernels. The plus operator adds their outputs while asterisk multiplies them. This allows me to create more sophisticated kernel functions to model complex data relationships. Adding kernels together combines their effects. It's like getting the best of both worlds. For example, combining a linear kernel and a RBF kernel can model data with both linear and nonlinear components. Multiplying kernels creates a more complex interaction. Imagine it as creating a more specific lens to reveal more nuanced patterns in your data. This would often make the function nonlinear. This is great if you need a model that responds to more complex relationships between your data points.